20 years ago, literally, April 2004, I wrote this 2-page, actually only 1.5-page thought piece. You can find it on the web, okay? Just Google for this title and you'll find it. It's from April 2004. It's called Augmenting Cognition. And in it, I'll just extract what is relevant today. I said, imagine a wearable computer with a head-up display in the form of eyeglasses and a built-in camera. This would offer the essentials of an augmented reality system to aid cognition. When you look at a person, his or her name could pop up, possibly with additional cues, reminding you to guide your greeting. Such magic glasses could transform your environment. Pure science fiction. 20 years ago, no, this is pre-iPhone, pre-Google Glass, pre-Vision Pro, pre-HoloLens, right? Long ago. Fast forward 20 years. A lot has happened. In AI, the entire field has been transformed by deep neural network-based cognition. And as long ago as 2011 feels like ancient history, we were already beating humans at things like Jeopardy. Wearable hardware, to this audience, I don't need to belabor the point. Even these devices look pretty ancient. And then something I personally have been involved in, which is very important for the story, is the ability to bring enough compute at very low latency to devices like this, which are challenged by weight, size, heat dissipation, battery life, etc. You cannot make these too light, too small, or have too much battery life. People are always asking for improvements along these attributes, okay? And so the way you can achieve those while having the compute to do those kinds of algorithms is by offloading computation wirelessly onto edge-based cloudlets that provide you the compute needed. And so at the intersection of all of these capabilities is the work that I'm about to describe in wearable cognitive assistance. So what is this? Imagine this person, she's wearing Google Glass, but it could be any device of the kind that is being discussed here. In real time, all of her sensor streams, audio, video, accelerometer, gyroscope, all this other stuff, is transmitted wirelessly at very low latency to a nearby cloudlet, which does real-time AI algorithms on those sensor streams, fuses them, and then gives her useful guidance in real time, faster than she can think. If you could do that, this would transform many, many, many walks of life. And the good news is it's not science fiction. You can actually do it. Now, how fast do we have to be? It turns out humans, remember, nature has had 1 billion years to evolve us. So the speed with accuracy with which we do things is amazing. Face recognition, 300 plus milliseconds on familiar faces. It takes a human being only 4 milliseconds to decide if a sound is from another human being. They may not know what was said, but that it's not artificial, that it's not an animal, that it's human. 4 milliseconds. Think of how useful this was for survival in the wild. Head tracking. If you have visual displays and you want registration, 16 milliseconds is the bound that you have. So this is to just match human speeds. If you're trying to be superhuman, you actually have to have enough budget left over to actually do additional work. So you need to beat these speeds in order to do the kinds of things that we want to do. So let me walk you through an example of how this could help. So today, imagine this guy is doing cooking. One of the earliest apps for Google Glass, now 10 years ago, was a cooking app. It showed you on the little display what to do next. Okay? So it's saying here, heat the oil till it sizzles. Very helpful. And then you can say next, and it shows the next step. Your hands don't have to get messy. You don't have to touch your smartphone. You don't need your cookbook. Great. But remember, what is missing? If a friend of his was standing next to him, he or she would say, wait, the oil is not sizzling. You're going to make a mess of this dish. The sensing of real-time data, knowing what you're trying to do, and in real time giving you feedback, that closing of the loop is what wearable cognitive assistance is all about. Okay? Now, this may seem very cool, but every one of you, perhaps even today, used such an application, except you didn't think of it that way. At least a few of you in the room have gray hair like me. So you remember these primitive things called paper maps. Right? Which way am I holding it? Where are we on this map? How do I get to it? Right? You know how painful. Now we've made it trivial. You follow the steps, it tells you, you make a mistake, it catches it, it corrects it. Could you use extended reality in the form that I've described to you, wearable cognitive assistance, to do the same for other things, more sophisticated things? GPS navigation depends on one sensor, GPS satellite-based location. But we have computer vision, we have audio, gyroscope, accelerometers, huge numbers of other sensors. And so we have created an open source platform called Gabriel on which to create these. We now have close to 10 years of experience. There's a whole bunch of published work. All our code and our applications are open source, so you're welcome to get them. And there are many, many use cases. We have only scratched the surface, and we haven't even done all of the ones I'm showing here. We've done some subset. Clearly, assembly. This we have explored. You have a complicated kit. It guides you step by step to putting it together. If you are a repairman trying to fix a broken piece of equipment, this translates to real money for a company that is helping to maintain those facilities. Think of every airline where the plane is delayed leaving the gate with 100 passengers inside it. Shaving 10 minutes to help you get this done sooner, more accurately, with the technical staff right here, rather than having to wait for somebody, just compute the value. Medical training. That is a mannequin, not a real person. But the teacher is a real human. Why can't I replace the teacher when I'm working on a mannequin with augmented reality? Right? Similarly, checking whether an elder person is putting on the instruments correctly. And my favorite, imagine this device yelling in your ear, don't do it. Eat an apple instead, okay? So, we have also explored the possibility in real time, if the app is not clever enough to understand what you're doing, to escalate this to a remote expert. So basically, on-demand Zoom call, if the software app is out of its depth or confused, if it's done something it has never heard of before, it doesn't know how to cope with it, you can now have a human voice. So instead of a call center where you call in and you have AI to filter it, you flip this on the head. Most of the time, the wearable cognitive assistants deal with you. You don't need a human in the loop. But as an exception handling mechanism, you can seamlessly glue the person in. And 3 weeks ago, we also demonstrated how to use large language models, ChatGPT, to help create these kinds of apps. So this is something you can purchase on Amazon. In fact, it tells you the date I purchased it, March 23rd, 2023. on the web at this URL. There's this guy. I don't know who he is. I've never met him. I've never, but he's created a helpful video for people to put this together. It's a very complex kit, 3D printer. We have been able to use that video, use the closed captioning from it, to basically create the core logic of the wearable cognitive assistant for this. So what took many weeks of software development time, we are able to shrink. Now the computer vision part still has to be done manually, but at least the logic of the workflow is now substantially accelerated. So this is very exciting. My point here is we don't have to wait 20 more years. Fortunately, in that same article, my last sentence was very valuable. It says, it's hard to predict when systems of this kind will become off-the-shelf products. They're not products yet, right? They're still research prototypes. At the moment, they do not even exist as lab prototypes. This is not true. They do exist as lab prototypes. Compelling visions of the future have a habit of becoming true sooner than most think possible. And centers such as XRTC, a center that's being created here, are going to be crucial to really making this vision come true. That's it.